Alright, what's up guys? Today we are back looking at Advent of code from last year. So if you've been following the channel for about a year now, you will have seen me actually do these challenges before, but last year I was doing them in Rust. As I mentioned in my previous video on OCaml, I'm going to be redoing these in OCaml just because I think they're really nice little self-contained challenges for learning a new language. So you can see here, I've got day 1 calorie counting from Advent of Code 2022 pulled up. And we also looked at this recently with Zach, if you've been following those videos. Now the challenge today is to loop over files that look like this. And each of these little clusters represents one elf in the story. And adding up these numbers gives the total number of calories that each elf is holding. So I think the first thing it wants us to do is find the elf with the most calories, and then report how many calories that elf is holding. And then in the second case, we'll be looking for the top 3 elves, and I think adding those up. So that's the outline of the challenge. Now I can do this in like 10 lines of Rust, so pretty easy. But of course today the focus is on actually writing some code in OCaml. So to help me out here, I've got the book Real World OCaml pulled up. I did look for a dark theme here. Couldn't find one, so sorry. Now, you may be able to see over here, I've actually got the physical copy of this book that I've been reading through. And I've gotten down to, I think I just finished chapter 17. So I've read most of the book by now. But I haven't written very much OCaml, as I mentioned again in the last video. So we're going to try to fix that today. I've also got the documentation for the base library pulled up. So base, I probably mentioned last time, is basically a replacement standard library. Yeah, to be a more complete standard library with richer APIs, and to be more consistent in its design than the actual built-in standard library. And this comes from Jane Street. So we're going to try to put that to the test. I've got my Emacs pulled up over here. And I've got to try to remember the command. I'm pretty sure it's dune init proj, and then I give it the project name. So we're going to call this one Advent OCaml. We better we'll throw a 22 on there as well, because we might be doing Advent OCaml in 2023 as well. We'll try that. And I actually suspected that might be the case. I've got to use underscores. Alright, so we'll go ahead and hop into Advent OCaml 2022. Do we want to look at any of this? Yeah, this is kind of like a cargo.toml file, I think. And then we should have a binary. We also have a lib that we're not going to be using probably. So yeah, we can go ahead and hop in here. We're going to try working inside of just the binary for now. And yes, I will import. I feel like you want to, I guess we'll do this. We'll take the suggestion. Okay, so the first thing we're going to do is dune build, just to clear out all of our, all of those errors. Now, if we make a change, okay, good, that should go away. Now I have to remember how to run this. Let's look at our dune file and see what this is called. Public name. Okay, name is main. So I think I should be able to do dune exec. Yeah, I remember forgetting how to do this last time. I've got the dune quick start pulled up over on my other monitor. It does say dune exec project name. Apparently, I guess I have to do this. Yeah, okay, so the root of the project really should be probably up a directory, but we'll see how it goes. So there's dune exec this. The other thing we can do is we should be able to do Tuareg OCaml, run OCaml. And I am going to use the actual regular OCaml REPL today, because I really don't like how utop looks. Let's try this. Let f of x equals x plus 1. I'll try sending that, and we'll just try f of 5 is 6. Okay, good. So we can send things over to our REPL in case we need that. And this is kind of nice, I think, because it seems a little bit hard to print things. Like you have to do print inline, and I'm pretty sure that this only prints a string. Now, so it's like we have to use what do you have to do, like string like of int unbound, something like that. I know they use something like that throughout here. Maybe we have to open base. Is base open? Open base. Base is not bound. Okay, now that I think we can fix in our Dune file. Libraries. Let's see, how do we add dependencies? Let's look at files, modules, and programs. Open modules. We'll try this one. Yeah, we're basically looking for where they talk about the Dune files. This looks about right. We figured this out last time, but I think I figured it out in my temp directory and didn't actually save the code. So where do we put this in our Dune file? Dune build. I think there's like a dependency directive. Maybe we just need the quick start here. Okay. Initializing projects. Oh, here we go. So this is with a preprocessor. Ah, you just say libraries. Okay, I couldn't remember the name of the directive. Okay, so we're gonna have base, and then we're probably gonna have to do dune build again. And now can I open base? And then we're gonna have to use standard IO as well. And we probably have to call dune build again. Now, I just read about in the book that we can do this. Dune build. Okay, let's stick with our compilation for now. We'll give up on the REPL. I've never been a huge fan of REPL-driven development. It's definitely convenient when you... it's definitely convenient in OCaml because you can, you just like test out some expressions. And probably we would be better off using utop. Because I think maybe... I just don't know why utop knows about my OCaml environment and the plain OCaml REPL doesn't. But anyway, we're going to try to solve problems. We're not trying to debug our environment right now. Alright, so we've got hello world working. Let's try to actually read a file. So I'm going to go ahead and create a test file. Yeah, we'll just call it test. No, there's a directory called test. We'll call it example. And we'll go back to advent of code and paste in our example. Okay, there we go. Now, I think I do have to go to the documentation to remember how to read. Actually, we'll go back to the book. They've got some good examples of this. Actually, I feel like I just read a good example of this. Maybe command line parsing. Basically, I just want to read the whole file into a string. We're not really worried about doing it a line at a time right now. And I do know that what we're looking for is in channel. Okay. Yes, that's great. Now, how do we actually create one of these? Do I can say in channel dot. Well, I guess we can just do this. Is it read? Really input? In channel. I guess we can just start scrolling. Close, input, input all. So it looks like we're going to have to create one, because this takes an in channel and returns a string. So we are going to want this at some point. So let's go ahead and do let load file name equal. At some point we're going to use this input all. But I guess at first we want in channel dot create file name. So that should return us an in channel. Binary hopefully defaults to false. Let's try piping that to in channel input all. And then let's just try printing. Well, maybe we do this. Load file. What did we call it? Example. And we'll pipe that to print inline. Try formatting that. And let's run it. Okay, well, that's not so bad. Well, great. Why does the formatter move that? That's kind of upsetting. But anyway, we're now loading our example file, and we're using print inline. So now we just have to actually process the file. So let's go look for a string split. Well, this is easier than I expected. Let's go look at the string module. Nope, that is not the right thing. We need the string module. So this is one thing that I dislike about OCaml already, is that whereas in Rust, you know, everything is like a struct with methods, everything in OCaml is like modules with functions. So if I want to split a string, I can't just have the value of the string and call dot split on it. I'm going to have to call like string split and then pass arguments. So it can look a bit worse, in my opinion. I guess it's more regular. You know, there's not this distinction between like methods and, I mean, I know OCaml does have methods on its objects, but most of the time you're just using functions. So I guess that's kind of nice. So we're looking for split. I was thinking about this a little bit, and we could probably do this with sum, or with a fold, but we'll stick with the basic version for now, where we're just going to try splitting. Now I'm pretty sure it is just string split. So we're going to move this down for now. Split. And I apologize for these colors. I think that is my fault. I have like the hard-coded colors that only look good for the light theme I usually use. So I need to take that out so the company will change automatically. Okay, so I think we should be able to pass this in, string split on, and we'll split on the new line. I guess this has to be a string, is that right? This expression has type string list. Okay, no, that's fine. Can we use printf on that? Does this work? I wonder what, is there like a print any? OCaml printf on a list. I was guessing A because I think that's what you use in Common Lisp. Okay, well, anyway, so we're just gonna have an error for now. So we load file example. We pass this into string split. I guess we actually want to split it on the double new lines, right? So that should give us the chunks for each elf. Then on each of these, we're going to do list dot map. And then I'll specify my function, which is going to be a lambda fun. We'll say elf. We will also do string split on a single new line, elf. And then once we've split the elves on the new lines, then I think, we are going to pipe it. Now I think we can use a fold. List.fold. So we've got, let me just hover over this so we can actually see it. We're going to be piping in the list Our init will be 0. And then our function is going to convert each of the lines to an int and then add it to the accumulator. So we'll fold init is 0. I'll just put a new line here. And our f is going to be another anonymous function. I don't know, I'll just say e for, it's part of the elf, right? And it's fun e, very funny. Int dot of string e. What does this return? Apparently it just returns an int. This is one interesting thing about OCaml too, is that it also uses exceptions. So you've got like both result types and exceptions. So it seems like you don't have to worry about results quite as often, because a lot of these functions just like throw exceptions if they don't work. Which in some respects seems like a bad thing, but it does at least make things more convenient. So basically we're going to do int of string e. Maybe we can actually do, oh, this is supposed to be e_ac, or is it ac_e? I don't remember. Let's go back to list fold. It's supposed to take ac first. So we'll just do ac plus int of string e. Oh, sorry, my dog is coughing in the background. Okay. Is this format at least? Whoopsies. I got an unmatched parenthesis. Okay, close this. So we load the file. We split it on new lines and then apply this function. Where we split each elf on this. And then do this. So this is adding up all of the elfs. Yeah, this is where the REPL would be really nice to actually see what's coming out of these. Okay, let's close this for now. We'll call this main. This should save, I think. What's the problem here? I'm trying to get... This is not a function. It cannot be applied. String split on... Let's try compiling this and see what happens. Okay, this function has type base string t. Now, I do suspect that we're missing parentheses. That seems to be a big issue in OCaml. I try to write things without parentheses, and then you need them. Oh, maybe I forgot a semicolon. Ah, okay. Oh, I think I forgot a pipe. Is it going to tell me this has to be a char? Oh, boy. String split. So we need to go back and look at string split. It has to be of type char. Split. What if I want to split on chars? Oh, no, that's one of the chars. Split lines? That's not exactly what we want. Can you really not split on multiple new lines? Okay, I think we just need to play around a little bit. Let's go ahead. We're going to close this. Where's our OCaml REPL? Kill it from Emacs? Alright, run OCaml. No, we're going to use utop. Because utop somehow knows what's going on. Let's go back to this. Let's go ahead and evaluate this. Whoa. Evaluate. evaluate. Now evaluate. See how much clutter there is here? Holy moly. So we just go and do load file, example. What the heck? Where's the output, dude? Load file, example. Isn't this supposed to return a string? I'm so confused. Is there an error somewhere that I don't see? No such file or directory. Okay, finally we get some output. Now I think it just doesn't know where we are. I'm guessing I need to do ... / example. Okay. Okay, there we go. Finally. Okay, and then I guess we probably have to split the list. Alright, let's just go... We'll do this the old-fashioned way, okay? Okay, so we're going to do let get elves. I don't know what to call it. We'll just make it take a list. Over list, init is actually going to be an empty list, and then f is this. What do we do inside of this function? If string dot equal elt empty. Oh, I bet there's an if is empty kind of thing. So if string equal elt empty, then let's return 0 const, oh, I'm supposed to do then 0 const ac, else match ac in, if it's empty, let's do let I equal int dot of string elt in match ac in. If the accumulator is empty, then I will just put it in the element I cons ac. If we get x, then we return I plus x. Whoops. And we can just do I. Else, if we have head, tail, then I return head plus I cons onto tail. Okay. Is that right? Let's format it. Is it match with? Maybe I was doing this completely wrong before. All right, we got match. Match. Searching it on the other monitor. Yeah, it is match with. Try that. I forgot this one. This doesn't exist. Okay, let's try to evaluate this. And now we should be able to pipe this to get elves. Okay. Is that correct? 10,000. Let's go back over here. 5, 6. Oh, it's reversed. That's okay. That doesn't actually matter. 10,000. 17, 24. 11, 4, and 6. That looks correct. So now if we do this, we should be able to pipe this to list.sort. We might have to provide a module for this. It looks like it didn't work. Let's go see how you actually call list.sort. List, looking for sort. I know it's not sorted. Oh wait, it should actually work, right? Compare. It looks like this has a default argument, right? Sort. Where's my... Where's the return value? Oh, do I have to give it a compare? Does that work? Okay, this is great. Now, how do I reverse it and compare? This is harder than it looks. Int. Compare. Ascending is identical to compare dot descending. Let's try this. Int dot descending. List dot take 1. Where's my list module? Take ln returns the first n elements of L or all of L. Oh. It takes the list as the first argument. It looks like I might have type a list. Yeah, it looks like the pipe is kind of getting that backwards. Okay, so load file. Then string dot split on this. Then we pipe that to get elves, which we then pipe. This has to be a character. Get elves. Then we pipe this to list sort. List.sort. Compare. Compare is int descending. I guess we have to assign this let L equal this in list.take L1. Of int, oh, how do we to string print end line? You can't just use a regular pipe. No. Returns the sum of fi. We can provide the f, which is this expression has type int list, but an expression was expected of type summable. Int list. An int is not summable? I mean, I know we can fold over it, right? List fold init 0 f is fun of x plus x. Unused value main. 24,000. That is correct. Okay. Holy moly. Okay. Well, that was quite painful. Input. So now we'll load file input. We will open input. Let's get our puzzle input. Get your puzzle input. Oops, write that. And we can run that 71023. 71023, fantastic. And then for part 2, we just have to take 3. Yeah, 71023 is correct. And now if I take 3, I get 206, 289, 206, 289. We got our stars. Have a nice day. I really can't help but say that every time. Russ Cox's videos were just amazing. Alright, well, I think I'm just rambling. That seems to be about as good as it gets. If you guys have a better way to do this, please let me know down in the comments. That's probably it for this video. But I'm probably going to pick up recording again the next video right away. So, let me know what you guys think about OCaml. Let me know how I did. It doesn't feel too good, but maybe maybe it's actually okay. Anyway, as always, thanks for watching. One final reminder, go check out the memberships. You could have seen this video a little bit earlier. And maybe we'll add some more member rewards once we get some members. So thanks again for watching, and see you guys next time.